In this video, we're going to talk about the algebra topics of factoring, solving equations, and looking at systems of equations. So first, let's begin with factoring. When we talk about factoring, we're going to include in here when you are able to factor out a common term. And what we mean by that, if you're given this expression of 12a squared plus 10a, you should notice right off that with the terms 12a squared and 10a, we have a common factor of 2 and a that we can pull out from each of those terms. So we can factor 2a from the expression. And when we do that, we pull the 2a out. It's like we are doing the opposite of the distributive property where we multiply back. So since that's the case, when you pull the 2a out to check, you can just multiply back through and make sure you come up with the original expression if you have any questions with that. But this is just a reverse application of the distributive property, pulling out a common term, factoring out a common term. We also see when we have to factor a polynomial and put that polynomial in a completely factored form. Most of the time, we're going to be looking at a trinomial in this form, usually like ax squared plus bx plus c, where a, b, and c are constants. You can usually factor these out into two binomials to produce that trinomial as a product if we went back in reverse and multiplied through using something like the full method. We're going opposite of full. Instead of multiplying together, we're pulling it apart into two binomials. So this might be such an example here. We have x squared plus 5x plus 6, and we want to get that in its factored form of two binomials. We can look at this and factor it into x plus 3 and x plus 2. So you might need a little reminder about how we can factor that. First of all, what I want to remind you of, if you have a TI-84 calculator, there is an application, the Polynomial Root Finder, that will help you find the roots or the factors of an expression. And if you need more information on that, there's YouTube videos, you can look that up. But your calculator will factor this. It will give you the roots, which you can also backtrack and find this form, x plus 3, x plus 2. You need to feel comfortable doing that. So if you're going to use your calculator for factoring like that, you need to practice it. Don't let the use of the calculator tie you down on time. Some of these are just very simple to factor out, and I wouldn't want to spend my time on my calculator. There are a couple of others that may be a little bit more challenging that you may want to. So to have that ability in your back pocket when you need it is a great thing. But let's just do a little reminder here. When you have a trinomial that you need to factor, somewhat in this form, what we want to do, what I always begin with, is looking at my signs. Our first sign here, which is the sign in front of the constant value, if it is a positive sign, that means that the signs of your two binomials will be the same. So then we'll take a look at the sign between our x squared term and our x. If it's positive, it means that both signs of the binomials are positive, and that was our case for our example problem. We had x squared plus 5x plus 6. The plus in front of the 6 means the signs are the same. In between the x squared and 5x was a plus, so we knew that both binomials were a plus. In this second expression we see here, the term between the x squared and x could be a negative. And what that means, the original first plus that we looked at, the signs were the same, and the signs would be a negative. Now what about if the sign in front of the c, the constant, is negative? So that means the signs are going to be different. And how we determine what those signs are is we look at the first sign between the x squared and the x. If that sign is a positive, that means that the largest value is going to be a positive. So in our example, when we factored into x plus 3 and x plus 2, the 3 is the larger value. It would have gotten the plus, and the 2 would have had a minus in front of it. Now, if in our second sign, the ax squared minus bx minus c, we know the signs are different, and the larger value gets the negative in front of it. Hopefully this will spark a memory if you're not 100% sure, and you will think if you need to work some example problems of this. But these are our 4 different cases. Be familiar with that. And again, like I said, if you have a TI-84, you might want to take a look at that root finder to help you. It may come in handy here on our next slide if we have to look at solving equations from factored forms of expressions. We can do that by looking at the values of the variables. That's what we're trying to determine. So we're going to make use of some of these skills we've been practicing, combining like terms, simplifying. We're going to move the variables to one side or the other and solve. So what we really want to do when we set up this is to put all our variables and constants on one side of the equal sign, and we want to set it equal to 0 to solve for the variable. So here's an example here. We're asked to solve for a. A is our variable, and we have 2a squared plus 7a plus 5. We're going to set that equal to 0 so we can hopefully factor and determine what the values of a are. So we factor this into 2a plus 5 and a plus 1. Now to come up with that, it's a little bit more challenging when we have a coefficient other than 1 in front of the a squared. You can take some of your techniques to factor to come up with these binomials. You can also make use of the root finder on your TI-84, and that actually gives you the answer straight up. But what we do from this form, we can set each of these binomials equal to 0. We'll have 2a plus 5 equal to 0 and a plus 1 equal to 0. And we can do that because we're multiplying these 2 binomials together. One or both have to be equal to 0. Then we have 2 algebraic expressions to solve. On the left-hand side with the 2a, we'll subtract 5 from both sides, then divide by 2, and we get a is equal to a negative 5 halves, or negative 2.5. That's what you would have gotten on your TI-84. It would have come up with the negative 2.5. And then for the right-hand side expression, a plus 1, we subtract 1 from both sides, and we get a is equal to negative 1. So here we have 2 answers, 2 values that a can be. Now let's take a look at systems of equations. So when we have a system of equations, that basically means we have 2 or more equations with the same number of unknowns or variables in each of the equations. And as long as we have an equal number of unique equations as we do unknown variables, we can solve. So if we have 2 unknown variables, let's say it's x and y, as long as we have 2 unique equations, we can solve. And there's a couple of different methods that we can use to solve a system of equations. If you've been through an Algebra 1 or Algebra 2 class, you've probably looked at each of these. The matrices method probably more so in Algebra 2. And that's one that could take a little bit longer to use. So a lot of times that's probably not going to be the method you use, but it is out there. What you're probably more familiar with is using substitution, elimination, or graphing to solve a system of equations. And the method that you choose is going to be based on several things. Which method you understand the best, how much time you have to solve the problem, and then given the question that they've given to you, which method makes more sense. So for example, if you're given a question, you're not given any graph or anything, and you begin to graph it, that could take you a little bit longer as opposed to maybe doing a substitution or elimination method. So it's great to practice all the different types so that you'll know which one to apply at the correct moment. Just a thing to keep in mind about a couple of special cases when you're solving equations or even systems of equations, you could come up with an infinite number of solutions. You may have heard this is like all real solutions, something like that. So when you get an answer, when you solve your equations and your variables cancel out and you're left with something like 3 equals 3, a true statement, just a number. Notice there's no variable in there. It's a true statement. 3 equals 3, 5 equals 5. Or if you're graphing it, if when you end up graphing the 2 or more equations, however many you have, they're graphed all on the exact same line, one on top of the other, that's an infinite solution question. In turn, from an infinite solution question, you could have the result of no solution. This is when your variables cancel out and you're left with something like 3 equals 5. That is not a true statement, right? 3 is not equal to 5. So, or if you're graphing them, you get lines that never intersect. 2 parallel lines, something like that. Those lines will never intersect. They will never cross because our solution on a graph is the point of intersection where the lines intersect with one another. Parallel lines, they never intersect. There's not a solution to those expressions, to those equations. So keep those 2 special cases in mind as you're working through any ACT type questions. Now let's take a look at this example problem. Try to work this here, pause it, and we'll come back and work together. It says, which of the following expressions is a factor of the polynomial x squared plus x minus 20? And if we glance at our answer choices, they have already given us a binomial, one of the factors. So there's several different approaches that you could take to this question. What I think I'm going to do is I'm just going to try to factor out the original that I'm giving. Not even looking at my answer choices, what would I get if I factored? So I take my original expression, I'm going to factor that into x plus 5 and x minus 4. Notice the way I did that, I looked at the sign in front of the 20. It was a negative, minus 20. I knew the signs would be different. The sign between the x squared and x is a positive. That tells me that the larger number that I multiply together to get 20 is going to take the positive. The smaller number gets the negative, and that's where we get the x plus 5, x minus 4. So it says, which of the, and we go back to answer our question, which of the following is a factor? So I'm looking for either x plus 5 or x minus 4 in my answer choices, and I see A is x plus 5, and that's going to be our answer.